Hey everyone, I'm Chris, this is Vivian. Hi, we work for Lyft. We're the other transportation company open sourcing some certificate stuff this week. So we're excited to talk to you about what we've been doing, and so we'll kind of tell you about our project and what we've been doing. SSH.
All right. So today we're going to be talking about better SSH management with ephemeral keys, aka how we made SSH access a lot better at Lyft. One second. Technical. All right. So we're going to start off talking about how we used to do SSH management at Lyft. And then we'll talk a little bit about Netflix's Bless and how Netflix uses Bless for their SSH access in their infrastructure. Then we're going to talk a little bit about how we used and adapted Netflix's Bless for our infrastructure and our purposes. Followed by talking about how we're running our Lambda and client, how we're running the Lambda in our AWS infrastructure, and how we run the client on the engineers' laptops. And then we'll briefly talk about the shortcomings that we came up with and how we had plans to fix them. All right, so what we did at Lyft before. During onboarding, IT would provision laptops. They would set them up before the engineering starts at Lyft. So one of the things I had to do in the process was generate a private and public key SSH pair for the engineer. So this was done by IT, not the engineer. They would generate the key, store the private key in the .ssh folder as usual, and then they'd put the public key in a file that it was salt managed, and this would bring the public key into the authorized keys of the user on every host on our fleet using salt management. So this file looks a little bit like this. It's a YAML file, and it has a few properties such as my name, my email, and most importantly, my public key. So this file was a file that's stored in a Git repository, and it's used in salt management. It's run, and the data in it is used to put authorized keys into all of the instances on our fleet. Sorry. Okay, so that worked well for a while. So we had engineers who had laptops that already had the SSH key on them. They would be able to SSH right from day one using the private key that was provisioned to them into any of the instances on our fleet. So this was good, it was functional, but there were a few problems with it. So firstly, like I said, the engineer themselves didn't make their own key. This was done by IT. So this isn't great because someone else potentially knows your private key, and we had to make sure that IT followed the right process to generate a secure enough private key, SSH key pair, and make sure that this process was secure enough, which we couldn't because we couldn't have the certainty that that key wasn't stored somewhere else during the process. So yeah, that's that. The process was prone to human error. So like I said, the public key had to be copied onto this user's YAML file every time someone was onboarded. And if there was a typo in it, then there'd be a typo in the authorized keys. And then we'd have to redeploy this salt management to all our fleet every time there was an error. And this deploy process could take anywhere between 20 to 60 minutes because it had to run on all our instances. So this wasn't the greatest process for rotating a key. And furthermore, because of this slow rotation process, if a key was compromised, so for example, if the engineer's laptop was stolen, then this would result in having to rotate the key, which is the same deploy process, which means that a malicious user could have up to an hour with the key and have SSH access to our instances like that. So that's not great. Finally, this process doesn't have two-factor authentication, which means that once someone has the private key, that's it. They have SSH access into all instances. There's that. That's not the greatest process. Okay, so introducing Netflix's Bless. So Netflix recently, maybe not so recently anymore, but they open sourced their AWS Lambda Bless. So Bless is an AWS Lambda. It stands for Bastion's Lambda Ephemeral SSH Service. And basically, it's an AWS Lambda that issues SSH certificates to its Bastion. In case you don't know, AWS Lambda is basically serverless computation. What we would do is we would upload Python code to AWS Lambda, which would have some sort of handler like the Lambda handler function. When the Lambda is invoked, it can be invoked with a payload. This payload is passed to this Lambda handler function. The Lambda handler does computation, and then it can output a JSON response. So in the case of Bless, the input, the payload, would be a public key. The computation would be a CA signing this key, and then the output would be a certificate that could be used for SSH. A cool thing that we get for free with Lambda is that we can use AWS IAM permissions to control who can invoke the Lambda. So in the case of Netflix, the Bastion can invoke the Lambda, and we can make it so that only the Bastion can invoke the Lambda and nobody else can do it. Okay, so the output, like I said, of the Lambda is a SSH certificate. If you're not sure what an SSH certificate is, it's basically a certificate signed by a CA signing the public key, an SSH public key. A server can be configured to trust a list of CA fingerprints. So, for example, in Netflix's infrastructure, they probably have a list of Bless Lambda CAs and the fingerprints on every machine. And anyone who presents a certificate that with a fingerprint that matches a CA fingerprint that they trust will be granted access. The cool thing about certificates, its advantages over public key, is that you can specify a couple things. So for example, you can specify the principals. For example, who is using the certificate. So you can, for example, narrow that down to just Vivian Ho. Only Vivian Ho can use the certificate. Only the Bastion can use the certificate. You can specify the valid to and valid from dates, and that gives you the option to issue short-lived certificates. So in Netflix's case, they only issue certificates that last for 2 minutes. After that, you'd have to call the Lambda again. We can also specify the IP addresses from where you can SSH using the certificate. So you can specify where you can SSH from, and you can also specify a bunch of other principles and features. So it's pretty cool. So briefly, how the Lambda works. The Lambda is in the middle of this diagram, and inside the Lambda, it has the CA. The CA has a private key. It's password protected, and the password is stored with the Lambda. But the thing that makes it so that only the Lambda can sign with the CA is that the password is encrypted using KMS. And the KMS key is protected using IAM permissions such that only the Bless Lambda can decrypt with the KMS key. So that means that only the Bless Lambda has access to decrypting the password and using that password to sign. So as you can see, the user on the Bastion can request a certificate. It will give its public key to the Lambda. The Lambda then decrypts the password using KMS, uses this password and this private key to sign the public key, return a cert back to the Bastion, and then the Bastion can use this cert to SSH into any instance on the infrastructure. All right, so like I said, there's many good properties to using SSH certificates, such as the be able to specify the principals, the source IP addresses, the valid to and valid from dates, and a bunch of other principals. So those all come for free. Like, those are all options you can have with the SSH certificate. We can also use IAM policy to prevent anyone from invoking the Lambda except for the bastion. And also, again, IAM policy is used to ensure that only the bastion can decrypt with the KMS key to get the password for it. The AWS Lambda is running on a separate security account, which is the standard security practice in AWS, because if you run on a separate account, it's much harder to escalate a privilege in another account up to that account. Running sensitive things in, such as the Lambda, in a separate account is something that Netflix does, and so we do the same thing with our Lambda. This process is a win for us because all we need to do is provide a list of trusted CA fingerprints to each of the instances in our fleet, which is just a one-liner modification to the SSHD config. So we don't need to install any PAM modules or anything, which is something that we might have had to do if we considered other options, such as using Duo or Duo for MFA. Okay, so that was Netflix's Bless. Lyft's Bless is similar to Netflix's Bless. We just adopted it for our purposes. So with our Bless, we just made it bastionless, such that every engineer can invoke it. So like I said, Lyft's Bless is really Lyft's less. There is no bastion. Any engineer has the permission to invoke the Lambda. And we use kmsauth to mint tokens for the engineers that can authenticate the user. All right, so briefly how our blessclient Bless works. It's a little bit more involved than Netflix's Bless. The user, not the bastion, invokes the Lambda. But before it invokes the Lambda, it actually generates a kmsauth token. And I'll go into a little bit more about what that involves later. But it generates this kmsauth token, which can validate the user's identity. So it has this kmsauth token. It passes the kmsauth token along with its public key to the Lambda. The Lambda checks the kmsauth token, validates that the user is really who they say they are, and then only after then it will do the same thing as the Netflix's Lambda, where it decrypts the password using KMS, and then signs the public key, generates a cert, gives it back to the user. The user now has a cert and is able to SSH into our instances. We do have a bastion, but it's more just for EC2 proxying. So the bastion accepts the certificate, and then all the other fleet instances in our fleet also accept the certificate. So the user is the one with the certificate rather than the bastion. All right, so what is kmsauth? This token that magically identifies the user and proves that they are really them. kmsauth is Python kmsauth is a library that we open sourced a while back. And basically, it uses IAM permissions to ensure the verification of the user who's generating the token. So with KMS, we can specify the encryption context, and in IAM permissions for KMS, we can restrict what the values for the encryption context can be depending on the user. So in the case of kmsauth, to set up a KMS key that works for this, you would restrict the from of the encryption context to only be the username of the person. So I would generate a kmsauth token, and the only from encryption context I can say, so the only token I can generate on behalf of is myself. I can't, the from context has to be Vivian Ho, it can't be Chris Steipp for example. So because of that assurance, I would get a token. I would say the to context would be the Bless Lambda, the service that I'm giving a token to. The from context would be me, Vivian Ho, and then this token would be sent to the Bless Lambda as part of the payload. On the Bless Lambda side, the Bless Lambda would be able to decrypt the token and check the encryption context, and it will see it's from Vivian Ho, which means that it's definitely from me. And it can have that assurance because of IAM policy. Only I would have been able to mint this token. Like I said, in Lyft's Bless, you have to give the kmsauth token as part of the payload. If you don't give it, then it just doesn't work. Lyft's Bless validates this kmsauth token to ensure that you are really who you say you are. And the process of invoking kmsauth and the process of invoking the Lambda both require multi-factor authentication. When the user calls the Lambda on their laptop, they need to type in the 6-digit code they get from their phone. Otherwise, they wouldn't be able to invoke the Lambda in the first place. So with these measures, we can be assured that the Bless Lambda is actually being invoked by the person who they say they are. All right, handing over to Chris to talk about the Bless client.
All right, I'm a little taller. All right, so obviously this is a little bit more complex. So when we're looking at options, for adding two-factor to our SSH authentication, we looked at Duo, we looked at a couple other things, and like you said, we wanted to do something that didn't require PAM modules. We liked a lot of the properties of certificates. But one thing that we had to do was actually have an agent running on the user's laptops to actually do this whole process. So that is something that we've open sourced now. So as of Friday, our Bless client is open source. Yay! So you can go there and you can read lots about it. What does this client do? So essentially, sorry, I have to look behind me a lot. So we have the agent running on all the developers' laptops. It invokes the Lambda, so it does that whole process on the diagram, gets a kmsauth token, talks to the Lambda, gets a certificate, and then injects that certificate into the user's SSH agent, as well as having it on the hard drive. But one of the hard requirements that we had, and we'll talk a little bit more about kind of our operational requirements, but one of the things we wanted to do is make sure that unless the user is actually putting in their MFA token, everything needed to act exactly like normal SSH. Our Lyft is very much of a DevOps shop, so all of our developers need to access their hosts just like normal SSH. If we got in the way, they would get very upset with us. So thank you so much. So that was a hard requirement for us. So a lot of the trade-offs that we're talking through here were done to make it easy for our users, even though probably from a security perspective, we may have tried to do something different. Cool. It's open source, and so please, we would love to, there's a lot of work to be done. We would still love to recruit volunteers for that, but it's also free, it's open source, so you can go and check it out yourself. All right, so the things that we really liked about the certificates, again, users have to put in their MFA before they actually SSH, which was a huge win for us. We do it every 18 hours, so we require kind of that verification of liveness every 18 hours. The certificate is valid for 30 minutes, and it's basically the window where we have to re-talk to the user, revalidate that the user's AWS account is still active. So every 30 minutes, the user talks back to the Lambda and gets a new certificate, and we save that certificate for 30 minutes. This is all logged in CloudTrails, which is awesome, and yeah, slight modification from the Netflix's Bless. That again is open source. If you look at our fork of Netflix's Bless, there's a couple patches there. Just some minor things. The kmsauth being the biggest piece there. All right, so being a security person, I came to Lyft. Like I said, we practice DevOps a lot, which meant that we as a security team, we wanted to set this up, but that also means we have to run this. And we have to be like critical path to engineers SSHing into their instances. So that was a challenge, and so as a security person, it was an experience, and so I thought we'd share some of those with you guys in case you want to run this too. So. Number one, just running the Lambda. It's really easy to say like, hey, we'll get this thing from Netflix and we'll just run this Lambda. It was actually a little bit of a process. So a lot of those Lambdas are, they're serverless. So you have to give AWS everything it needs. So you have to go and you have to like pull down. You have to compile all the Python libraries. Uses the cryptography library, which is a native library. You have to get that all compiled up, zipped up into a tarball, and then actually upload it to Lambda each time, which will create a new version. We had to build a container to actually go and do that. So every time that we update our libraries, we can just kind of, in our dev environment, build a new set of libraries, tar it up, and upload it to the Lambda. Right now, we're actually doing some like AWS CLI to actually do the uploads because Salt, just the Lambda management modules of Salt were kind of recent, and so we're kind of having to deal with some like old Salts, and so we haven't been able to do that. Versioning and aliasing. Lambda has some cool things. It will create a new version each time you upload a new code base, and then you can point an alias at a particular version. So this let us, one, we can change our Lambda, and we're not going to impact users. We know that they're going to keep using the same good version of our Lambda, and then if we make it version incompatibility changes, we can have just 2 pointers and then point clients to the new version. Actually deploying the client out to users' laptops. We have a dev environment that all of our employees get set up with basically day one when they start at Lyft, and part of that is installing the blessclient, getting their AWS credentials sitting on their laptop, and being able to SSH in. It sets up in a virtual environment because it's a Python script running all of our users' laptops, and then it's just a script that gets generated through a pip install. We have to ensure the client is actually called. So if we only get a 30-minute certificate, we have to actually make sure that the blessclient is invoked whenever the user needs to SSH. So the way we do that is with 2 ways. We alias SSH. So if a user just types in SSH to their host, we actually invoke a wrapper script that invokes bless first. Optionally, maybe ask the user for their MFA if they need to, and then goes ahead and runs bless to get the recent cert. We also put a match exec call, which is kind of a more recent. I think it's OpenSSH 6.1-ish. Maybe it was 5.9. I forget when they actually put this thing in. But that actually lets the SSH itself go and invoke a command when SSH is run. And that picks up things like rsync and all the other commands that we didn't want to alias. So that was nice. We push out a client, so again, speaking as a security engineer, I'm like, auto-updating, this is kind of scary. But when, operationally, we push out this, we get all of our users to go update this, we really needed a way to actually be able to push out changes, push out security updates, those types of things to our users. So we did build in auto-updating. So every 7 days, basically, the agent checks back in, pulls down a fresh copy of it. And this is not in our open source version, but in the version we're doing, we actually check a GPG signature, and we check out the most recent valid signature tag. All right, so again, operationally, we want this to be fast. We really were concerned that if we push this out, if it takes like seconds every time the user invokes SSH, this is not going to be tenable. If you're responding to a page at 2 a.m., waiting for 5 seconds is not an option. So we need everything to work really fast. So we had to end up caching a lot of things. So we do cache our kmsauth token for 60 minutes. The user credentials are cached for 18 hours. So basically, the user has to put in their MFA once every 18 hours. And yeah, our certificates are good for 30 minutes. All right, so just talking about a few of kind of the limitations and the challenges that we ran into as we were rolling this out. So again, one, Lambda. So we were actually one of the first teams at Lyft to be using Lambda heavily. There were some kind of toy projects, but basically we were the first ones to really do it. So we didn't know how Lambda was going to fail for us, and we really didn't want to fail in the middle of another outage and have teams locked out of their boxes. So we knew we needed to run in 2 regions. So we set up in US 1, which is where we run everything. We run a lot of other things in US West 1, but the AWS doesn't give us Lambda there, so we had to run in US West 2. Not a big deal, but that was just kind of a weird thing we hit. we did know that if Lambda totally fails across all regions, then we needed some way to get into our boxes. So we actually pushed 2 CA fingerprints to all of our boxes, and the second one is kept by the security team. And so if we need to, we could go in and actually manually issue SSH certificates to our users if for some reason all Lambdas everywhere have gone down. That has not happened yet. We've actually been very happy with the performance of Lambda. It's also pretty cheap, so it's actually been a really good use of our time and resources. And when the great DNS thing happened last September and East region basically went down, we didn't automatically fail over, but users were still able to hit the West region and get SSH certificates, so that was good. Other issues we've hit, KMS rate limits. AWS recently changed how they do the rate limiting, so it's you're actually at a flat cap, 100 encrypts or decrypts per account now, which was really disappointing to us. Used to be rate limited by key, and so we knew that if we failed because of a rate limit, we could always go to another KMS key in a different region. And so now we're actually capped on that, and that's something we've been very disappointed by. But we're trying to figure out ways around that. AWS MFA, we thought all of our users had a good AWS, their MFA token set up with their account. When we actually rolled this out, we realized a lot of users had set this up when they onboarded, never actually used two-factor for anything. So it's been something that we had to, as a security team, we suddenly had to actually set up 2FA for basically our entire data science team and a couple other engineering teams that didn't MFA much. Speaking of our data scientists, apparently we thought Python was standard across platforms. At Lyft, most engineers use Macs. We have some Linux, not much Windows, but we thought Python, it's standard. But turns out it's not. So yeah, data scientists have Anaconda and other weird things that say they're Python. They take over Python on the user's laptop, but it's not Python, and it causes all sorts of issues. So as a result, we're actually considering possibly porting all this to Go, just because Python's been one of the struggles that we've had. Unconventional shells, we try to alias things, but then fish comes along, and aliases don't really work the same way, so it's been a challenge. Boto libraries, when we were running on Lambda, the AWS, they can go and upgrade your Boto libraries whenever they feel like it, so we've been hit by that a couple times. Oh yeah, and we cache our MFA token. Not a huge fan of that. So what does this look like now? Basically, user gets their AWS credentials. They download the blessclient as part of their development environment, and they're immediately able to SSH into all of our servers, which is awesome. If we need to deprovision, then we can just disable their IAM account, and they're really locked out. So lots of problems solved. Yay. We felt good about that. And that's the end. And yeah.
All right, thank you. So here's your gift from Fitbit. Thank you.